Welcome to Learn Biology, and we're still on the topic of basic chemistry, and today we're discussing covalent bonds. So before we get started with covalent bonds, it will be easier to first have a review by remembering that the goal of any atom is to have 8 electrons in its outer shell or lose all of its electrons and have 0 electrons in its outer shell. So, as an example here, we have 2 oxygen atoms. Here's, 2 oxygen atoms. They both have 6 electrons in the outer shell. Since oxygen is so close to the number 8, it only needs 2 more electrons in the outer shell. What it does is pull any other atom's electrons into its own shell so it can achieve stability. But the problem here is that we have 2 oxygen atoms of equal strength. There's a perfect opportunity here to have 8 electrons, but neither one can pull the other's electrons into its outer shell. So what happens here is that a covalent bond forms in which electrons are shared. So here we have a diagram of what it looks like when 2 oxygen atoms combine. Let's call this oxygen atom A, and let's call this B. What happens is that these two are equally strong. Neither one can pull the other's electrons into its outer shell. So what happens here that a sharing of electrons occurs? What happens is that A gives 2 electrons to B and B gives 2 electrons to A, and this forms a bond in which the 2 oxygen atoms join together with 4 electrons in the middle. So now both of these have 8 electrons. Now before we move on, we need to understand another principles of atoms. So we have this thing called electronegativity, and this is what explains why oxygen pulls electrons from other atoms into its valence shell. Electronegativity describes the attraction of electrons in order to achieve stability, and how this goes is that the more right you go in the periodic table, the greater electronegative force we have, so an increase. And why this is because the more right we go, the closer the atoms are, or the elements are, to achieving stability. So what this means is that fluorine has a really strong electronegativity compared to, let's say, hydrogen, or oxygen has a very strong electronegative force than hydrogen. And this leads us to something called polar and nonpolar covalent bonds. What polar means is that the bond creates poles. Now on a magnet, poles have positive and negative charge. This is exactly what a polar covalent bond has. For example, here we have H2O, water, 2 hydrogen, 1 oxygen. So what happens is that the oxygen is negative and the hydrogens are positive. We have discussed this in other videos, but this goes into in-depth of what causes this. So what causes this is electronegativity. Like we said, oxygen has a strong electronegativity. It pulls electrons from other atoms, and hydrogen here has a very low electronegativity, so it is forced to give away its electrons. So back to our diagram here. So here we have water, and we see that oxygen is strong, so S for strong, and hydrogen is weak. But what happens here is that oxygen only needs 2 electrons to achieve stability. So what it does is, in the presence of hydrogens, it creates a sharing or a covalent bond and shares electrons. So this hydrogen gives 1 electron, its only electron, and this hydrogen gives us only electron, and oxygen now becomes stable. So 8 for stable. At the same time, like we said, this is shared. So oxygen gives 1 of its electrons. So now we have 2 here. And oxygen gives 1 of its electrons. So hydrogen too becomes stable, slightly more stable than it's already, and now has 2 electrons in its outer shell. But like we said, oxygen has a strong electronegativity and hydrogen has a weak electronegativity. So what happens is that oxygen pulls at electrons a lot more than these hydrogens do, and this creates a charge. It's like having a tug of war kind of competition. So if we have a rope here, and here's the center, and here are 2 people, and let's say, and then here's another person, and let's say this person is stronger. So let's say this is the electron, and this guy is strong, this guy is weak, so this electron will always be closer to this person. So that's the same thing that happens with oxygen and hydrogen, and this creates a charge and makes oxygen negative and hydrogen positive. Now, there's also a nonpolar bond in which if 2 of the same force atoms join, then there is no charge, so no poles. And what happens is that they equally pull and no charge occurs, and both of these just stay neutral. So thank you for watching Learn Biology, and we will see you next time.